Assistant Professor of Computer Science Engineering Department from Akgec Engineering College. Today we discuss the topic Introduction to Machine Learning Techniques. This is the first unit of BTech third year students. So first we know the what is a machine learning. So machine is basically a model, a computer or a technique, and learning is basically understanding of the knowledge. So machine learning is the part of the in this image. Deep learning is a part of machine learning. Machine learning is a part of AI or subset of AI. So machine learning basically is a part of computer science or artificial intelligence, in which focus on the data and algorithm and improve its performance. So in the field of computer science, the machine learning is defined as a technique in which computer programs automatically improves their performance through experience. In machine learning, author Samuel, machine learning enables a machine to automatically learn from data, improve performance from experience, and predict things without explicit programmed. So, and next author, Tom Mischel, gave the machine learning definition: a computer program set to from experience E with respect to some class of task T and performance measure P, if its performance P at task T as measured by improve its with experience E. So in machine learning, basically three traits in which we will give the definition of machine learning. So three important concepts: experience E, task T, and performance P. So machine learning is basically used of various applications like fraud detection, image detection, speech recognition, product recommendation, and so many things. So real life example is a machine learning is a fraud detection, image classification, face recognition. Now next topic is learning. The learning is the ability to improve the behavior based on the experience. So learning is basically an understanding of the knowledge or a behavior. So learning is the process of acquiring new understanding, knowledge, behaviors, skills, values, attitude, and preferences. So the ability to learn is the process by human, animals, some machines. There is also evidence for some kinds of learning in a certain plants. So now next topic is a well-posed learning problem. Yeah, well-defined learning problem. Both are the same, so don't be confused. So in well-posed learning problem is defined as the three traits. First is a task. In a task, we will classify and predict the data and prediction. In a performance measure, we indicate the P. And in performance measure, we improve the efficiency and problem solving approach. And experience E shows the data, past data. So some examples of the define the well-posed learning problems. So first is to better filter emails is a spam or not spam. So we classify the what is a task, what is a performance, and what is the experience in this example. So filter email is a spam or not a spam. So in this example, task is a classifying email is a spam or not a spam, and in this performance measure is a fraction of emails accurately classified as spam or not a spam. And in experience, observing you labels email as a spam or not a spam. Now second example is a checkers learning problem. So in checkers learning problem, task is a playing checkers game, and performance percent of games won against opponent, and experience in which player are win the game against the opponent. Now next example of well-posed learning is a handwriting recognition problem. In handwriting recognition problem, task is recognizing and classifying handwritten words from a given event, and performance measure percent of uh, percent of words correctly classified, and experience is a database of images of handwriting words. Now, next example is a robot driving problems. So, in this example, task is a driving on a 4-lane highways using a vision sensors, and performance measure is a average distance traveled before an error, and in experience is a sequence of images and steering commands recorded while observing a human driver. And now next and last example of the well-posed learning is a face recognition problem. In a face recognition problem, task is a predicting different types of faces, and performance measure is able to predict maximum type of faces, and experience is a training machine with maximum number of data sets of different faces images. Now our next topic is a types of learning. So types of learning is basically 4 types: supervised, unsupervised, semi-supervised, and reinforcement. So first is a supervised learning. So supervised learning is a type of machine learning algorithm that learn from the labeled data. Labeled data is a data that has been tagged with a correct answer or classification. So labeled data basically comes from name, tag, symbols. So in supervised learning, as the name indicates, has the presence of supervisor as a teacher. In a supervised learning, in which we teach or train the machine using data that is a well labeled. For example, a labeled data set of images of elephant, camel, cow would have each images tagged with either a elephant image or cow. So all these images are tagged with all these images symbols are tagged with a name. So supervised learning is basically a classified in a 2 types: regression and a classification. So regression is a type of a supervised learning that is used to predict a continuous value like house prices, stock prices. Regression algorithm to learn a function that maps from the input features to the output value. So some common regression algorithm: linear regression, polynomial regression, logistic regression, support vector machine regression, decision tree regression, and random forest regression. Then next is a classification. So classification is also a part of supervised learning, and in a classification used to predict categorized values such as when email is spam or not spam, or whether a medical image shows a tumor or not. So in a classification, we use the different types of algorithms like regression, support vector machine, decision tree, navy Bayes. Now our next topic is unsupervised learning. So in supervised learning, we use the labeled data set, but unsupervised learning, we use the unlabeled data set. That means there is no tags. So this means that the data does not have any pre-existing labels or categories. The goal of supervised learning is to discover patterns and relationships in the data without explicit guidance. So unlike supervised learning, no teacher is there. Means no training will be given to the machine. Therefore, the machine restricted to find the hidden structure in the unlabeled data set by itself. So unsupervised learning is basically a classified 2 parts: clustering and association. In a clustering is a type of unsupervised learning that is used to group up similar data points together, which means clustering is a collection of homogeneous and heterogeneous peer groups of the data. So now next algorithm of unsupervised learning is association. So association rule mining is a type of unsupervised learning that is used to identify patterns in a data. And association rule learning is basically follow the if-then else rule concepts. Now next types of learning is a semi-supervised learning. So in a supervised learning, we use the labeled data set, and unsupervised learning, we use the unlabeled data set. So in semi-supervised learning, we use the combinations of data sets like supervised and unsupervised, like labeled data set and unlabeled data set. So basically, semi-supervised learning is a combination of supervised and unsupervised learning. Now our next type of learning is a reinforcement learning. So basically, a reinforcement learning is a reward based learning or feedback based learning. So in a given figure, in this reinforcement learning is one agent is here. So agent is a perform the some action or task to the given the environment and get the some rewards on penalty. So reinforcement learning is a type of machine learning in which desired behavior is rewarded or undesired behavior is punished. So it is basically a reward or feedback based learning. So our next topic is designing a learning system. How to design a machine learning model or a learning system. So designing a learning system in a machine learning is a multi-step process that ensure the system is effectively efficient and adapt to the real world challenges. Each stage is built on a previous one to create a robust framework. So in designing a learning system, first step to defining the problem and objective. So the foundation of learning system begins with a clear problem definition. Start by identifying the type of task the system aims to solve, such as a classification problem, regression problem, or a clustering problem. Now our next step is a data collection and preparation. So in a step 2, we first data is a backbone of any learning system. Collecting and pre-processing high quality relevant data is a critical for the system success. So in a data gathering, data can from databases, API, or real-time systems. For example, financial forecasting, many real on stock market data sets, while medical system use patients record. In data processing, we remove the inconsistencies or missing words, values, and detect the outliers and normalize to scale features. Data cleaning ensure the data is ready for training and minimize errors caused by poor quality of data. In designing a learning system is step 3, the choosing the training experience. So decide on the type of training experience based on the problem and their nature of the data. So which type of data we use for training and testing, like supervised learning, unsupervised learning, or reinforced learning. If you use the supervised learning data, best for tasks where labeled data is available, such as predicting loan defaults. If we use the unsupervised learning data, suitable for uncovering hidden patterns in unlabeled data set. And if we using the reinforcement learning, then ideal for dynamic environments like robotics or gaming, where the systems learns through trial and errors. Now step 4 is selecting the target functions. The target functions define the relationship between inputs means features, and desired outputs, and the predictions or output. So for example, a target function for loan approval model that might depend on the customer income and credit history. So if a customer income is a high, then loan approved. If customer income is low, then loan is rejected. So step 5 is choosing a representation for target function. So choosing the appropriate representation for target function depend on the problem complexity and data characteristics, like which type of data we use, decision tree, neural network, or linear model. These steps requires for balancing model complexity within the probability and computational efficiency. Now next step is selecting a function approximation algorithm. So in this step, select a learning algorithm that effectively approximates the target functions like gradient descent, support vectors, machine, k-means, clustering algorithm, and in different type algorithm choice must align with the problem type, data characteristics, and performance effectiveness. Now next step is training the model. So after evaluating, train the chosen model using the prepared data. This involve iteratively feeding the data into the algorithm, adjusting model parameters to minimize errors using techniques like back propagation in neural network, and apply the monitoring the training process to avoid the issues like overfitting, which occurs when the model perform well on training data set and but poorly on unseen on new data set. Next step is evaluate model performance. So after the training and testing, evaluating the model ensures its generalizations well to new data, and use different techniques for evaluating model performance like validation split, cross validation, and different types matrices used like accuracy, precision, recall, mean squared error, ROC, AUC curve. And this evaluation process identify weaknesses in the model, guiding further refinement. So now our next topic is history of machine learning. So first, machine learning is basically introduced 1950 to 1960s. So the first machine learning algorithm were developed and were based on idea from psychology and statistics. The next machine learning is that come from 1970. Machine learning began to be used for practical applications such as image recognition and natural language processing. In 1980, support vector machine were introduced, which allowed for more accurate and efficient classification of data. In 1990, the rise of statistical learning algorithms like Bayesian network and hidden Markov models led to breakthrough in the areas such as speech recognition and machine translation. In 1997, the IBM computer Deep Blue, which is a chess playing computer, beat the world chess champions. And next, in 2000, the advent of deep learning such as convolutional neural network, recurrent neural networks, and long short-term memory network were introduced. Now the 21st century, today machine learning used in a wide range of fields like AlphaGo for use the game permutation and combinations, image recognition and object detection, speech recognitions like Siri, Google Assistant and Alexa, recommendation systems like Amazon, Netflix, and medical diagnosis and predictions. Now our next or last topic is issues in machine learning. So machine learning has several problems like inadequate training data, poor quality of data, non-representative training data, overfitting and underfitting, monitoring and maintenance, data bias, lack of skilled resources, slow implementation and results, and imbalanced features or bad recommendation systems. So these are the several issues in machine learning systems. That's all.